finally, in our previous video, we have seen till here, we have understood what is the convergence algorithm and how we can actually update our theta value, which is my coefficient, based on the positive and negative slope. And this was the theta or coefficient updation formula. Here, alpha also we used it, and this specific alpha was nothing but learning rate. Now, I really want to make one final conclusion and probably write some more equations, and we can just consider that till now, we saw that we have actually covered something called as gradient descent, right? And gradient descent, whenever we talk about gradient descent, so in short, we are talking about that curve. Okay, so in short, we are talking about this specific curve. And this curve is basically, we get it from when we try to plot with respect to theta and j of theta, right? So over here, you'll be seeing that this is the curve that we usually get. And our main aim is basically to come to this global minima, right? So this global minima, and we try to update our theta based on this, right? Basically, we try to find out whether the slope is positive or negative, and based on that, either I need to update the weights, increase this specific coefficient, or decrease the specific coefficient, which I have actually explained over here. Now, for our example, we had actually considered what? That our intercept is 0. That basically means our best fit line passes from this to this. And since it passes through this intercept, so we considered theta 0 is equal to 0, and we were changing theta 1 value. Okay, so this was basically changeable, right? We did not focus more on theta 0. The reason why I did this is that because I wanted to show you the gradient descent in the 2D diagram. So over here, when I'm drawing this is basically in the 2D diagram. Let's consider that theta 0 is not 0. That basically, let's say that if it is not passing through the origin, then this 3D diagram may look something like this, right? So let's say this entire diagram will look something like this. I am just creating for an example. So it may look something like this. Okay. It may look something like this. Let's say consider that it is coming, it looks like this. So theta 1 may be somewhere here. Okay. Theta 0 may be somewhere here. And our main aim is basically to, merge towards this global minima, right? So our aim is basically come to this global minima. So this will also get updated like this, and this will also get updated like this. And finally, we reach the global minima. So that we usually do in a 3D diagram. And obviously, I cannot draw a 4D diagram, but just understand it's like a inverted mountain. And from the bottom, from the top, you are basically coming to the bottom, right? So bottom at one single point. So this particular point will be the global minima. Now, if I consider theta 0 and theta 1, let me go ahead and write my convergence algorithm. Okay. So what was my convergence algorithm again? So I'm just going to update my convergence algorithm. Okay. And the convergence algorithm was pretty much simple. Here, I will say that repeat until convergence. The same thing what I have written on top. Okay. Repeat until convergence. But here, my theta j will get updated something like this, right? So theta j is, see this symbol that I'm using, right? This is a continuous iterative process. So that is the reason I'm writing this colon and equal to. So it will just get updated with respect to this theta j minus alpha, which is my learning rate, and then derivative of theta j. Okay. And one point I have to use is nothing but j of theta 0 comma theta 1. Right now, since my theta 0 is not 0, so I have to basically find out the derivative of both these things now. And you know that what is j of theta 0 comma theta 1? Okay, we already explained it. So j of theta 0 comma theta 1 is nothing but our cost function. So if I know my cost function, it is nothing but 1 by 2m. Summation of I is equal to 1 to m. M basically means how many number of data points I have. And then I have h theta of x of I minus y of I whole square, right? So this is the cost function that I specifically used for j theta 0 comma theta 1. Now my main aim is basically to go ahead and calculate this, right? Derivative. Now I'll try to just show you. It's okay if you don't know derivatives also, guys, but understand our main aim is to basically converge to the global minima, right? So here I will just go ahead to write something like this. I'll just try to calculate this. And over here, you know that since you have theta 0 and theta 1, your j value will be 0 and 1, right? 0 and 1. So let me just go ahead and write it over here. So derivative of theta j, okay, with respect to j, theta 0 comma theta 1 is equal to derivative of theta j, okay, and I have over here 1 by 2m. I'm just replacing j theta comma 1 with the cost function, right? Whatever cost function I'm writing. So 1 by 2m summation of I is equal to 1 to m. Okay. And then I have over here h theta of x of I minus y of I whole square, right? So this is my entire derivative of j theta 0 comma theta 1. Okay. And let's go ahead and try to find out the derivative of this. Now guys, it is simple, right? If I take an example, if probably in your high school you have learned about derivative basically means we're trying to find out the slope. Suppose if I really try to find out the derivative of x square, right? So what I will be getting with respect to 6. See over here I'm trying to find out the derivative of x square with respect to x. So this will be nothing but 2x, right? It's just like n x to the power of n derivative is nothing but n multiplied by x to the power of n minus 1. So this is what is the formula, right? So similarly, I'm going to apply this derivative for this particular equation. But when I'm finding the derivative, I have to find it for j is equal to 0 and j is equal to 1, right? So I'm just going to write over here if j is equal to 0, right? So if j is equal to 0, this entire equation, what it will become is this entire equation, this entire equation will be becoming derivative of theta 0, j of theta 0 comma theta 1, which is nothing but derivative of theta 0 1 by 2m, and here I'm basically going to use summation of I is equal to 1 to m, and this will basically be, I'm just writing the same thing, right? H theta of x of I minus y of I whole square, right? So this will be my entire thing. Now here you can basically see that fine, I'm getting this exactly. Now I'll just go and find out the derivative with respect to theta 0. So if you know this equation, always remember this is just like your x square. This, let's consider this is my entire x square, right? So x square will be nothing but 2x 2 minus 1, right? Something like this. So whenever we have this x square, whenever I try to find out the derivative with respect to this, it will be 2x 2 minus 1, right? This is what is the basic formula. Okay. So these are simple derivatives, guys. If you don't know, don't worry. Okay, but just I'm trying to write out the convergence algorithm with respect to theta 0 and theta 1, because now we have a 3D graph, 3D curve, which will try to converge in one single point. Okay. So finally, here I can basically write after this, in short, if I really want to write, so this entire value will get converted to something like this. So it will be nothing but 1 by m, because 2 will be there, this 2 will come down, so 2 and 2 will get cancelled, and here you can basically write summation of I is equal to 1 to m h theta of x of I minus y of I whole square. Okay, so here sorry, not whole square, because 2 will go down, right? So this is my entire derivative, and h theta of x, you know, right? What is h theta of x? H theta of x is nothing but theta 0 plus theta 1 x, right? So if I try to find out the derivative with respect to theta 0, so this will be 1, and this is actually a constant, right? This entire thing is basically a constant, right? So this will basically become 0, right? So theta of 0 will be 1, so it will be multiplied by 1. So in short, we will just be getting this specific term. Okay, so I hope you are able to understand it. What we will do is that while finding derivative, right, we'll replace this h theta of x with this equation, right? And since we are trying to find out the derivative with respect to theta 0, first of all, it will be 2x, okay? And then we'll try to find out the derivative of this particular equation, okay? And here we know that if I try to find out derivative of theta 0 with respect to this 0, so here I'm going to get 1, and this is a constant, this will become 0. That is how derivative actually work. Now similarly, with respect to j is equal to 1, I'm just going to find out the derivative, and this will now change as derivative of theta 1, j of theta 0 comma theta 1. Okay, so here you can see derivative of theta 1. Okay, and then I'm going to just apply for this specific equation, and it will be same thing, summation of I is equal to 1 to m, and let me just equate this as theta of x with theta 0 plus theta 1 into x. Okay, theta 0 plus theta 1 into x. I could have replaced it over here, but it's okay. This is what I will be getting, right? Now we are just going to find out the derivative with respect to this specific equation. Now in order to find out the derivative, it's very simple. Again, I'm going to take this entire 2 down, so this will be 1 by m, and here I'll be getting summation of I is equal to 1 to m h theta of x, which is nothing but theta 0 plus theta 1 multiplied by x Okay, then it will be minus y of I. Okay, so this will be my entire thing. Then this entire thing will be going to the next step. Okay, and from this you know that now theta 1 is not a constant, right? Because we are trying to find out the derivative with respect to theta 1. So just imagine, like, if I'm trying to find out the derivative of theta 1 with respect to theta 0 plus theta 1 x. So what will happen? So over here theta 0 will become constant, theta 1 will be basically getting a derivative. So here, in short, if I try to find out the derivative, this will be x. So I'm going to just multiply by x over here, right? So this in short will be actually helping us to find out the derivative with respect to theta 1, right? So this is my entire derivative with respect to j is equal to 1. Okay, I have just taken this and found out the derivative, it is x, so I have multiplied with x. Okay, so these are the two things that we really need to write. So finally, I can quickly write something called as repeat until converge. This will be my final statement and final conclusion with respect to simple linear regression, repeat until convergence. Okay, and here we will be basically using two important equations. First of all, we need to keep on updating theta 0. So theta 0 will be nothing but theta 0 minus learning rate 1 by n, right? So what is theta 0? See, with respect to theta 0, this is what over here I need to replace derivative of theta 0 with respect to j of theta 0 comma theta 1. What is derivative of j of theta 0 comma theta 1 with respect to j is equal to 0? This is my entire equation, right? So I'm just going to write this entire equation over here. So it will be nothing but 1 by m summation of I is equal to 1 to m, and here I will be seeing h theta of x of I minus y of I. Okay, and then theta 1 will get updated as theta 1 minus learning rate, and derivative of j theta 0 comma theta 1, what is the derivative we got over here? This particular equation, right? So here I'm going to basically write 1 by m summation of I is equal to 1 to m, and again I'll be having h theta of x of I minus y of I, and here I'm going to use x of I. Okay, so this is my entire equation that I specifically get, and this convergence will be happening unless and until we get the best fit line, or we get the we basically get the best fit line, or we converge to the global minimum. So this is the entire thing that you really need to know. I know there are a lot of equations that has been used, but again, understand the phenomena. What we are actually doing, we are converging in this gradient descent, right? If I use theta 0 and theta 1, then it becomes a 3D curve, right? 3D curve. And at the end of the day, theta 0, wherever it is, we have to come to the global minimum. So I hope you have understood it. If you find any difficulty with respect to the equations, don't worry. Okay, because implementation of some amount of theoretical knowledge is required. If you don't know the equation also, implementation will be quite easy with the help of a scalar, right? So yes, this was with respect to simple linear regression, and in the upcoming videos we'll see some kind of practical implementation. Thank you.